everyone. So in today's video, we are going to find the optimized way to find prime number. So before we start, let's understand what is a prime number. A prime number is a number which is only divided by one and itself, and it's the number. For example, for example, 13, 2, 5, 3, BC. So now let's move on and find the efficient way to find this. As we all know that a prime number, factors of a prime number will always exist in pair. For example, when we take 24 here, what will happen? Each, each factor, the first factor would be 1, then 24. Moving forward, we will have 2, then 12, then 3, 8, 4, 6. At this point, uh, it has it has already got its half of its factor. Then again, after its half of its factors, we will see that the all factor will repeat back. So we can see here clearly that again 4 and 6 were the factor earlier, and now it's 6 and 4 means they are both are same. Similarly, 8 and 3, 2 and 12 and 2, and 1 and 24. 24 and 1. Sorry, 24 and 1. As we can see clearly here that the first that uh, first factor the first factor uh, is less than the other factor in each case. So here 1 is less than 24, 2 is less than 6, 12, 3 is less than 8, 4 is less than 6. So what we will do, we will run a loop till its half, which is n by I. We will run till we will run till the loop run the loop till n by 5 n by I. So this is a concept we are going to use, but we will check whether I should be less than n by I, which means I square would be less than I, and I square will be less than n. So this is the concept we are going to use in the prime number. But before I go into the programming scene, let me tell you what that here it would be equal to. Let's know why it would be equal to. So the reason why it will be equal to, let's take example 6, which has two common factor, means where we will get only one factor rather than two, not a pair. For example, n is 36, then we have to take, we will get 136, 136 to 18, 12, 3, 4, 9. And at this point, we will get a pair of two factors which are same, 6 and 6. So this is the reason. After that, it will repeat again. 6 equals to 9 is to 9, 9, 4. So at this point, where 6 equals to 6 is there, we will we will run iteration of a loop till I is less than equal to n, I square is less than equal to n. That is the reason take why we take I square is less than equal to n. So now let's move forward to the coding scene and find the efficient way and do the code in the efficient way. So now I've come into Geeks of Geeks coding screen. So let's find. So here we have been given a question that the user will give n value to the uh, program, and we have to find whether it is prime number or not. And we have the challenge to do it in O and half. Time complexity should be O and half. So let's do it and see whether it works or not. So what we will do first? First, we will check whether first we will make sure that the I is 1 because it will start from 1. As we know that prime number will have two factors. Every prime number will have two factors. It won't be greater than that. So what we'll do, we'll first run the loop till half of its pair of factors I into I is less than equal to n, and moving forward, this would return sorry it would return number of iterations, which will be half of n, which will be half of n times, because we will get pair in we'll get the factors in pair. So moving forward, let's take care of indentation, otherwise it will return a error. So here it is what we will do. Yeah. So if if n divided by I equals to 0, here we are dividing n by I. We will we will we will then check whether is not equal to n by I. Let me explain you why we have taken this. Why we have taken this. So going back to the screen. So we have done uh, if I equals to n by I, to make sure that uh, in the earlier example where n was 36, we have seen that we will get two pair of factors that would be 6 and 6. So we are just checking here whether I is not is whether it is equal to n by I or not. If it will be n by I, then we will take the factor as 1, not 2. So back to the screen, coding screen, and now let's do the further part of the question. Yeah, so if this is equal to n by I, that is, if I will be equal to I, we will count the factor as c equals to c plus 1. First, we have to make a counting variable c equals to 0, and else if it is if we have two pairs, then it will count c equals to c plus 1. No, earlier c plus 2, because we have two factors in each division other than the similar, other than the same similar pairs. So we will return, will then we will check after the end of the loop whether c equal to 2 is equal to whether c equal to 2 is there or not. If it is equal to 2, then we have two factors of a number. When we have two factor of the numbers, we will return n is prime. We return that it's prime. So what we did wrong in this code was that we were dividing it by I, which we have to do. We have to find whether the remainder, when we divide the n by I is 0 or not, and we were doing that. We were not doing this. We were just dividing it, so it won't return 0. And here also, as it is a while loop, so we have to add I equals to I plus 1, so that it moves to the n, moves to that I square moves to n it, till half of iteration. So what we will get here is the answer as yes, each in prime case, as you can see the code work, and this is the answer. So we have passed all the cases, and this is what was the answer of this question. That's all. Thank you.